All right, so today it's just a little bit of an extension over what we have been doing. We've been doing SOHCAHTOA. SOHCAHTOA stands for sine is equal to the opposite over hypotenuse, cosine is equal to the adjacent over hypotenuse, tangent is equal to the opposite over adjacent. We could do a problem like this where I say the angle is 30 degrees and I'm looking for this side right here. And let's see, if I'm looking at this, this is the opposite, this is the hypotenuse. So I would say sine of 30 is equal to x over 10. X is equal to 10 times the sine of 30. You go to your calculator, whatever calculator that you're using, and I would do 10 sine 30, boom, and that's 5. Okay, and now I would know that this side is 5, and that's the type of problem that we've been doing. But today, I'm going to ask you, what if the problem had looked like, what if I had the 5 and the 10 from the beginning, and I was looking for the angle? Well, you should know what the angle is already, because we just did it using 30. But I want to show you that I can do sine of 30, and I get 1/2. I picked 30 and I picked sine because that's a nice, neat number. If I pick pretty much anything else, I'm going to get some kind of long, irrational type number. But what is interesting is above these buttons, sine, cosine, and tangent, you have sine -1, cosine -1, and tangent -1. So remember that I said that sine of 30 is equal to 1/2. You might ask yourself, what do you think sine inverse of 1/2 is equal to? Well, guess what? That's 30. Okay. So in math, inverse functions undo whatever you did. Like if I add 6 to a number, I can get back to where I started by minusing 6. If I multiply a number by 7, I can get back to where I started by dividing by 7. Okay. And so if I sine 30 is equal to 0.5, when I sine inverse 0.5, I'm going to get 30. And if I sine inverse 0.587785, I'm going to get something close to, I'm looking at these numbers right here, I'm going to get something close to 36. Not exactly 36, but that's because of the rounding error. So if I have a question that's like this, now I would want to say x is equal to, or if you want to see the whole thing, how the algebra works, sine of x is equal to 5 over 10. The way I undo sine of x is I raise everything, I do everything to the sine inverse. So if I sine inverse the left side, I have to sine inverse the right side too. This cancels and I get x is equal to sine inverse of 5 over 10, which is 30. If I'm looking at the activity here, it's one of these jokes. What did the aliens say to the eggs? It's funny, you're going to laugh. You probably won't be able to stop laughing, but that's your problem to deal with, not mine. What I would do, you don't have to use the little mouse. You'll see how slow it is going with the mouse, but I'm just put it up here so that you can. If I label this, actually let's do a different one because this one is sine inverse. Let's say if I label this right here, this is adjacent and this is hypotenuse. So what's my adjacent and hypotenuse function? I think that's cosine. So I'm going to do theta is equal to cos inverse of I can use my pen. 2.95 divided by 6.46. And then I can do that on my calculator. Cosine inverse of 2.95 divided by 6.46. This is second cosine inverse of 2.95 divided by 6.46 equals 62.8. And so let's see, where is 62.8 on here? 62.8 is an M. That was number 2. So I'm going to put an M here. That's the only M. All right, so that's how you do that. This is only if you've already finished all the other Delta Math activities, which means you are you're ahead of the pack. You're doing well. I appreciate your engagement, and this should make sense. And let us know if you have any questions.